Good morning, my dear students. We are solving for two hinged arches uh, among the topics in Unit 1 of SA2. Till the last session, we have solved for two hinged arches with circular geometry, and in this session, we will take up parabolic arches of two hinged in nature. Okay, so what will be the modification or change in the formula that we have derived for the horizontal thrust, so that we need to take up to what to substitute for different values that are available in the H equation. Okay, right. If you see in general, the generalized H equation, what is derived earlier from the theorem of least work using strain energy due to bending, right? So integral m dash y ds by ei in the numerator divided by integral y square ds divided by ei in the denominator. This is the generalized equation in general for arches, right? Okay, now in case of circular arches, what we have done is we have converted all these Cartesian coordinates like y and ds and x, everything. Do you get x in m dash where we write beam moment. So all those Cartesian coordinate values you have converted to polar system, which is r and theta. Right. Now you are now taking up the parabolic geometry, where the geometry is a parabola. So to work with parabola, Cartesian system is comfortable. So we need not change the Cartesian coordinate system available in the equations. For example, m dash you write in terms of x, so let it be there. And similarly, y you have to convert that y into using the relation between x and y. You have to convert into the integrand term that you get by changing this ds. Okay, so what do you write for ds in case of parabolic arches? So this is a relation that you have between dx, dy and ds. So if you take an element of length ds in the arch, so that you can project it onto x-axis, that is its projection, and you can project it in onto y-axis, its y projection. So if you write now cos theta, right, so it will be dx by ds. Okay, so it is dx by ds, right, where you have to replace ds, right, in terms of dx, because you are proceeding with Cartesian system. So your equation should be in terms of dx, right? So to replace ds, what you are writing, dx by cos theta. So both numerator, denominator, as ds is getting I mean to say flexural rigidity is taken uniform. So numerator and denominator you will replace ds. So ds you replace with dx by cos theta in the numerator as well as in the denominator. So cos theta is going to be there in numerator and denominator, so it gets cancelled. So finally you are going to have a simplified formula for using no for parabolic arches in case of two hinged arches. Okay, so two hinged parabolic arches, you can use this formula for evaluating horizontal thrust, right? So that is integral m dash y dx divided by integral y square dx. Okay, and you have relation between x and y in terms of the geometry of parabola, that is y is equal to now 4h x into L minus x divided by L square. Okay, this is the relation between y and x. Y is also a variable. As x varies, now as x varies, y also varies. So if you want to integrate the variable y, your y should be in terms of x. So that's why you should replace y always with this expression. So then you can carry out your integration comfortably. So this is what is required changes to be made for the general equation available for horizontal thrust evaluation in case of two hinged arches. Okay, so what is replaced here is for ds is replaced with dx. Okay, and y is replaced with the geometry, parabolic geometry relation between x and y. Okay, right? So keep an eye on this formula. Please remember that for two hinged parabolic arches, to find horizontal thrust, we shall use this formula, right? We will take up an example and see how it works. Right, let us see one example. So determine horizontal thrust developed in a two hinged parabolic arch subjected to concentrated load P at the crown. Okay, so the given is a two hinged parabolic arch which is subjected to a point load. Okay, so what we want is horizontal thrust. So use the modified formula for this case. What is that? For a case of parabolic arch. Okay, so what you need to substitute here, you need to substitute for m dash and you need to substitute for y. So this is required, right? So what is m dash means what? Same logic. You take a beam of same dimension, okay, and apply the same load as that of the arch and take the same location of section xx. Right, now write mx, that will be your m dash value. So sum of all moments to the left of this section. So what you have, only reaction at A. Okay, so reaction at A is P by 2, as P is acting at the midpoint of this span, middle of the span. So reaction will be half of the load. So P by 2 into X is your moment to the left of the section. That is what is M dash. Okay. What is Y? The parabola equation for parabola. 4hx into L minus x divided by L square. So substitute these m dash and y into the numerator formula of h, the numerator value. We will separately find numerator value and then denominator value. Finally, we are going to divide and to get h value. Right, to get numerator, you see. So if you want, you can use symmetry because the given arch is symmetry. Otherwise, you can go with 0 to L doesn't matter. So because this equation is valid for 0 to L, so you can move from 0 to L, okay, right, as the symmetry prevails, right? Otherwise you can have symmetry. So 2 times 0 to L by 2, only half of the arch is considered, then that is made twice to get the total arch. So m dash is px by 2, then y is 4hx L minus x by L square dx. So that comes to, if you evaluate this integration, substitute for limits, so you will be getting 5 phl square by 48. Okay, so let us see how that is evaluated. Just very simple mathematics. Okay, so px by 2 is as it is m dash. Then what I have done is just 4hx, send it inside and separate these two terms. Okay, so multiply this with L first, then multiply this with x. Okay, separate the two terms. That is what is done. So 4hx by L square was there into L and L square. So denominator it will be L. Similarly 4hx multiplied by x will be x square by L square. Okay. So this is the next step of simplification. Right. Further, this 2 you can cancel out with this 2 if it is coming out of the integration, because it is a constant. Then similarly 4h and p, 4h in this, 4h in this also will come out of the integration. So 4ph, these are all constants. 4 is a constant, load is a constant, rise of the arch is a constant. Okay, even if you want, L can be taken out, otherwise you can just keep it out, keep inside, as it is going to be cancelled further, okay, in the process. So x by L is remaining here in the first term, x by L is remaining. Okay, so that no integrated, so what it will be, uh, sorry, x to be multiplied with this x, outside you have one x left over, so what you get here, x into x, x square by L square, one term, and x to be multiplied here, x cube by L square is remaining. Okay, this is further simplification, right? So once you take 4ph outside, what is remaining, x is outside this braces, outside this there is x, don't forget this, x is there. So send x inside, so x goes inside, x into x, x square by L first term, and x into x square, x cube by L square another term. Right, now go for integration process each term. So 1 by L is constant, so x square integration x cube by 3, so x cube by 3 first term, and integration limits 0 to L, L by 2. Okay, right, second term 1 by L square constant, x cube integration x power 4 by 4, this is the second term integration, right, limits 0 to L by 2. Okay, right, now substitute upper limit, as a lower limit is giving you 0, so lower limit if you substitute x is 0, it will be 0. Okay, so only upper limit has a value, so lower limit will not have any value, right? So just substitute upper limit. So place x is equal to L by 2, so L by 2 whole cube. Okay, it is L by 2 whole cube. So it will be L cube divided by 2 cube. 2 cube is 8. Okay. So L cube by 8 is numerator value. Divide by 3L is there. So L cube by 8 into 3L. Okay. Is it okay? Right. Next term. It is x power 4, which means L by 2 power 4. So which will be L power 4 by 2 power 4, 16. Okay. So L power 4 by 16, already 4L square is there in the denominator. Okay, got it. So now if you can take 8 outside, so it will be divided by 8 outside. So 8 you can cancel out. So 2 remains here. Right. So just a second. So it is 2 remains here. So 4 is outside already. So 2 we will have. So what do you have now? Even L, and it will be L square remaining. L square, L square remaining here. L power 4 is there in the numerator. So L square will cancel out and L square remains. So L square is common in numerator, that you can take it out. P into H is common. So P and H are out. So what is remaining then? So 1 by 3, first term, what you have is 1 by 3 is there, minus then 1 by 4 into 2. These two are remaining. Okay. So 4 into 2, 8 is remaining. So if you can simplify this, 8 minus 3 by 24. So what you have? 8 minus 3 is 5. 5 by 24 is this value. Already you have 2 in the denominator. Don't forget that. So 2 into 24. Okay. So which is equal to 5 in the numerator by 24 into 2, 48. Okay. So 5 by 48 is the number. Okay. So 5phl square by 48 is numerator value. Right. Got it. Let's just brief it. So you have used h is equal to integral m dash y dx divided by integral y square dx as a formula. So where you need m dash value. So to find m dash, very regular procedure, you take a beam of same dimension and same load, take a section anywhere and write for mx. That is what is beam moment. Then what is y? Y is if it is a parabola, you write parabolic equation for y is equal to 4hx into l minus x by l square. That you substitute into the numerator value. So what you have here, if you evaluate the simplification integration process will give you 5phl square by 48. Okay. Right. Let's proceed for the denominator. Now you see the denominator here, integral y square dx, and for a parabola this will never change. This denominator value is always same. Okay, for all parabolic geometry, because you don't have any load term in this denominator, so this will be always same. Right. Now you see how we evaluate this y square dx. So replace for y. What is y? 4hx into L minus x divided by L square. Okay. So you have to square this entire term. So let's first split this into two terms. Then we go for squaring it. Okay. So 4, you have 2 outside into, now 4 square 16. Okay. H square, got it. H square is also constant and will come out. L square in the denominator. So L power 4, let it be outside. What is remaining then? X square is there. Okay. So that we have x square into L minus x whole square. So what do you write? L square plus x square minus 2lx. Okay. So this is the denominator expansion. Let it be. Okay. 32 h square by L power 4. Okay. Now we send this x square inside. So what do you have? X square L square is there plus x power 4 is there, x square plus x square into x square minus 2l x cube. Okay. So this is what you have as an integration and dx. Okay. I'm just showing the steps of simplification only. So, right. Now you apply integration. So what do you have? So first term, you see L square constant. Okay. Let's this outside term, let it be like no change. 32 h square by L power 4 will be as it is. So L square is constant. We just keep it aside. X square integration x cube by 3. What are the limits? Limits 0 L by 2 because you have used 2 already. So 0 L by 2, right, plus second term x power 4 integration x power 5 by 5, limits 0 L by 2 minus 2L constant x cube integration x power 4 by 4. Okay, limits 0 L by 2, right. So this is no, right, keeping the outside term constant as it is. Now you have L square into x cube, substituting upper limit L by 2 here. So it will be L cube by 2 cube. 1 by 3 is already there. So 3 will be there. So x cube L by 2 whole cube. So what you have? L cube by 2 cube is 8 plus lower limit you need not worry, 0, right. 1 by 5 is there. Okay. 1 by 5 is already there. X power 5 you substitute L by 2 for x. So L power 5 divided by 1 by 2 power 5. 2 power 5 is 32. Right, minus 2L is already there. Divide by 4. So L by 2 I take. This 2 and this is 2 going cancelling out. So x power 4 you have. So L power 4 divided by 2 power 4, 16. Right. So these are the values inside the braces. So you can see the numerator in all the terms. It is L power 5 common. L power 5, L power 1 plus 4, L power 5. So L power 5 you can bring it out. So what you have in the denominator, L power 4. So what you have in the remaining, what you have in the no numerator, h square, denominator L power 4 and numerator L power 5. So what you remain with is 32 times h square L h square. Okay, denominator L power 4 is going to cancel out with L power 5. Only L remains in the numerator. Then what are all the numbers you have inside the braces? If you see, uh, 8 in first term and 32 you can replace it with 8 into 4, and here 16 you can replace it 8 into 2. So 1 by 8 you can bring it out. So 1 by 8 comes out. Okay, so 8 is not there now, it's taken out. What is remaining? 1 by 3 in first term. I'll just write it here. 1 by 3 plus second term 5 is there and 4 is also there, 20. So 1 by 20 is there, minus 1 by 2 and 1 by 2. So 1 by 4. Right? So this is the value that you need to evaluate. Okay. So what you have here, 8 fours. So 4L h square is already there, and you should multiply that with this number. Okay. So what you have here, now if you can go for LCM, right? 3, 20 and 4. So have 4 to be taken as LCM. 4 5s and 4 1. Okay, so it will be 20 into 3, so 60. I take 60 as LCM, I think. Okay, so 60 will be possible. Okay, right. So let's go for 60 LCM. So 3 20s, first value 20 and 23s minus 15 fours. Okay, so 23 minus 15. Okay, so how much you have is 8 by 60. So what you have here, 8, okay, by 60. Right, so to this number you should multiply this. It is 8 by 60. So 4 15s. Okay, so what you have, 8 by 15 LH square. This is the value. Okay, So this is a denominator value. So already in numerator we have evaluated 5 PHL square by 48. And denominator is now 8LH square by 15. So all the terms that you have which are able to cancel out. So what you get is 25 PL by 128H. This is the horizontal thrust in case of a two hinged arch applied by a point load at the crown. Okay, right. Thank you.